Ah, fancy meeting you here on the channel. I just wanted to share a little bit of information about why it is that we look so deeply into the sun, and it has to do with cosmology. In the mid-1990s, when I took college astronomy, I realized that there is a hole in the field of astronomy, and that is largely through sort of a low understanding of what's going on with the sun. Now, there are some people that are pioneering this, and that's a good thing. And basically, the reason that I'm doing these videos is because of cosmology, because our basis for understanding cosmology is based on what's going on that star. And in the realm of science, we often end up with answers to questions not asked, which is why I'm writing a paper explaining the mechanism underlying the solar sunspot and solar polar field reversal cycles. So anyway, welcome to the Daily Space Weather. It's only the most comprehensive space weather in the world, as well as the most detailed imagery you'll find of the sun anywhere. That's the last 24 hours from SDO. Large, well-defined North Pole-oriented coronal hole facing the Earth at the moment. That's yesterday and today's data so far in composite. 3 different wavelengths there, including 2 species of iron and 1 species of ionized helium. 2 new sunspot groups to get named today. Sunspot 3091 is this small group down here, barely visible, and Sunspot 3092, this larger alpha class group. We'll get more in depth into that later in the video. There's your SDO colorized magnetogram. This will be known as 3091, and this will be known as 3092. Let's take a look at volcanoes briefly to see what's been erupting. Abico, flight level 120. Mount Abico there producing a 12,000-foot plume of volcanic ash. Please don't pole vault the caldera. Ducono, 7,000-foot ash plume from Ducono. Popocatépetl exploding. 22,000-foot ash plume over central Mexico. It's at flight level 220. That's an uptick at Popocatépetl. Fuego exploding in Guatemala, flight level 160. Flight level 190 over Colombia from Nevado del Ruiz. Flight level 200 over Ecuador from Sangay. Flight level 160 over Ecuador from Revenador. It's a 16,000-foot ash plume. Sangay and Revenador both exploding. Also Sabancaya down in Peru exploding. A flight level 240. It's a 24,000-foot volcanic ash column. Don't pitch a campsite at the base of Sabancaya. Next, looking at global seismicity here, we've got moderate levels of activity. No major quakes over the past 24. One of the largest was certainly this 5.5 near Greece. And let's briefly check the location of that. In the southern Aegean there, adjacent to the Mediterranean there, off the coast of Turkey. And let's go back to the list. So that one and this 5.5 at the Fiji Islands. Those are the largest quakes of the past 24, it looks like. Had a 3.4 in Wyoming. Leave us a comment if you felt that quake. And just continuing up the list here, let us know in the comments if we've missed anything. The Owen Fracture Zone region also saw a 5.4. That is in the northwestern Indian Ocean. And now that we've done that, let's get back to our regularly scheduled footage of the closest star. This is ionized iron plus helium 171 plus 304 angstroms. And let's zoom out and look at just 304 angstroms. All that imagery also courtesy of SDO, the Solar Dynamics Observatory. The heck? Sorry about that. So we do indeed have one large sunspot group. That's 3089. That's this group right here. And the 10.7 centimeter radial flux has actually come down. It's only at 113 solar flux units. There's the 1-year graph of that. The black line representing the F107, or the 10.7 centimeter radial flux. 113 solar flux units is the current state. So space weather enthusiast dashboard here, not forecasting any geomagnetic unrest or geomagnetic storms. I would suggest that we are likely to see some geomagnetic unrest or geomagnetic storm conditions on September 2nd, early to midday. I could have sworn there was some ejecta headed our way, but we'll have to see what happens. And I don't think anybody agrees with me on this one. And let's take a look at the earthly geospace. So here's the last 4 hours of magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework. It's Earth's geomagnetic moment from space to about 12 Earth diameters. That's about the size of Earth's magnetosphere. And here's Earth's magnetic moment from the ground for the last 4 hours. We did see a brief period of geomagnetic unrest yesterday. Again, that's the last 4 hours of Earth's magnetic moment from the ground. So here's this brief period of geomagnetic unrest. Made it to a KP 4.33. Probably did spark some aurorae. I didn't see too much on Twitter. Make sure you follow us over there. If you don't have a Twitter account, create one. Twitter.com/SmashAmash Twitter, being held accountable for some of their pathetic censorship, I've heard. Maybe you've seen the recent Joe Rogan podcast with Alex Berenson. And thanks for leaving a comment, TinMan1057. Good morning to you as well from the Smash News Network. Least busted name in news. We still have an elevated solar wind here at about 545 kilometers per second. Looks like it's waning a little bit further here as we see the plasma temperature starting to drop down. That's the bottom pane, the green line. Current solar wind density just under 9 protons per cubic centimeter. Make that just over 9 protons per cubic centimeter. And there are your ghost magnetometers. That's the last 3 days of their magnetometer measurements from their geosynchronous near equatorial orbits. And let's take a look at the heliospheric current sheet. So Earth lies in a North Pole-oriented current sheet. The plasma, the solar plasma, it is polar in nature. And just a few days ago, Earth switched from a South Pole to a North Pole current sheet, or you could say the current sheet switched Earth, but in any case, that's the current state of affairs. Here's our line of sight plot. Oh, one other thing I would note is that we are seeing once again the North Solar Polar coronal hole region. As the North Solar Polar field migration is well behind the South. So here's our line of sight field plot. It also shows you the solar magnetogram, the sun's B field modeled here in blue. And here's our line of sight coronal hole plot. You can see this coronal hole coming into view. It is largely fixated around the North Polar region, although it does have trans-equatorial coronal holes there as the solar polar field migration process continues. It's in many ways the main feature of a solar cycle. Let's take a look at a little better visual analysis here. 211 angstroms there, ionized iron from SDO. Very well defined coronal hole there, should provide an additional high-speed wind. High-speed solar wind there coming in about 4 days. Also, we are expecting a minor CME impact tomorrow. Tomorrow, early to midday. We'll get to if there are any additional coronal mass ejections directed toward Earth later in the video. Here's our solar flare probability, and showing up as pretty high here, mainly as a result of sunspot 3089. At the moment, sunspot 3092 looking less likely to produce major flares. It's only alpha class, at least as far as we've seen so far. Sunspot 3091 is beta class, a little more magnetically complex, exhibiting both polarity umbrae. So here's the magnetogram from SDO for the past 24 hours. Things have been quite quiet there, and the active regions have been quite stable. Here's the SDO continuum. In the heck? What is up with that? There is one other small sunspot in the north there, fairly stable as well. Looks like it's only alpha class. It does have some beta class tendencies there. There is some trailing umbrae. And we'll show some higher resolution imagery of that later. Here's the X-ray flux over the past 3 days. Been quieting down as far as X-ray radiation. And once again, I would remind our viewers, do not get solar flares and coronal mass ejections confused. They are separate phenomenon. Solar flares are photons. Photons, meaning light in the form of X-rays. Coronal mass ejections are protons. That's gas. Gas and light are very different things. Please understand the difference. If you don't understand the difference, hold up a piece of paper and blow on the paper. That's protons. Then shine a flashlight at the paper. That's photons. Understand? Okay, let's move on. Another great wavelength to view X-ray solar flares is through 94 angstroms. And of course, the most likely places to see solar flares are the areas around those sunspots, those bright regions. That's the last 24 hours from SDO. Hence the term daily space weather. No spikes in the proton flux. It's been pretty calm as far as relativistic particles in the past 3 days. And next we always bring up a star chart to encourage you to get up before dawn. Check out Jupiter, Mars, and Venus. The third, fourth, and fifth brightest objects in the sky. And let's do a solar system forecast. We've got a crescent waxing moon at the moment. And let's advance this 1 week, as Venus is getting lonely on the other side of the closest star. And there's where things are on this side. 8 planets on this side, only 1 on the far side, as we'll have a gibbous waxing in 1 week. And welcome to September, the most geomagnetically active month of the year. So we're going to look at some coronagraphs here. Here's yesterday's imagery. And things have been quite uneventful here. Over the past 24, no new earthly directed coronal mass ejections. Here's today's imagery. And quite calm, you might even say boring, for the past 24 hours. We'll also show some imagery from Stereo A located here at Lagrange 5 and the Soho Lascaux C3. And I've paused this just because we've got some ejecta headed towards Stereo A there. Or is that far side? I think it's far side actually. But in any case, the more recent imagery, not a lot going on. Now for you new viewers, Earth would be off in this direction. From Stereo A's perspective, it will be behind you. from the Soho Lasco 3's perspective. And yeah, nothing headed down the earthly pipeline. You can see this dark region here. That is indeed the coronal hole. Again, we can expect a high-speed wind from that in about 4 days. And that should be quite a significant coronal hole high-speed stream there, as there are a lot of high-speed protons in that area. Despite it not showing up there, that's a characteristic of coronal holes. And here's the last 24 hours in SDO plus the Soho Lasco C2. Next, we'll head to Lermouth, Australia, to look at the ground-based solar observatory there. This is hydrogen alpha, and we see some massive filaments here rising in the southeast. Also quite a few filaments in the northern hemisphere. You see those dark absorption features? Those are filaments they could eject. But the most interesting spot is definitely down here around sunspot 3091. Huge filaments down there. We'll be keeping an eye on it. And when I say ion, well, it's here's some more ions. These are helium ions. 304 angstroms. From the GOES 16 SUVI, that's the last about 2.5 hours. This is what we usually stream when we're on Twitch. More on that in a moment. And here's the last 24 hours in 304 plus 171 angstroms. And it's time to move into bonus features. By the way, sorry about the volume being too low. We have adjusted that. Something did happen with the volume, and I think we've resolved that situation. Pardon the low volume. So there we got some minor charging hazards there, surface charging hazards around moving into the Central Pacific Ocean there, around moving into western Mexico and so on. Those shouldn't cause too much disturbance in your communications. And there is the GOES electron flux over the past 3 days. Those geosynchronous satellites are measuring electron flux from their geosynchronous near equatorial orbits using radiography. They're endeavoring to measure the electron flux at the F flare of the ionosphere, which we will also show momentarily. There's your relativistic electron forecast. Expecting an uptick there. No arguments from me there. And there's a 1-year chart. You can see we had a large swing there of electron flux over the past week or so, going from the highest level we've seen in a year down to the lowest level we've seen in months. And let's take a look at the F ionosphere layer, the area where those satellites endeavor to measure the electron flux. This is the vibrational frequency of those ions. In megahertz, that's millions of vibrations per second. And here's the anomalygram, just in case you're not familiar with looking at the ionogram. This will show you the anomaly in megahertz from a 30-day median. Again, we've just entered the most geomagnetically active month of the year, folks, September. You can expect some fireworks, as solar cycle 25 is, I'd say, barely halfway to solar maximum. So a lot more exciting stuff to come. Don't get bored, because the activity will suddenly rise. Anyway, there's the latest image, 10:15 Universal Time. Next, the total electron content forecast, showing you the most likely places for GPS errors. It's the free electrons between your GPS handset on the ground and your GPS satellite located on the inner portion of the outer Van Allen belt at about 12,500 miles of altitude. Total electron content here looking fairly normal. And there's a diagram showing distances to things in miles. Feel free to pause the video on this frame if you're not familiar. Here's the latest solar intensity gram and the latest colorized magnetogram. So first we'll take a look at sunspot 3089. Still quite magnetically complex. Still beta gamma delta class. And still underperforming when it comes to solar flares. Let's take a look at these regions over here. Oops. There's sunspot 3092. And sunspot 3091 is down there. Let me bring that up also. There's sunspot 3091. That's beta class. And this group up to its north, that is alpha class so far. Those are all South Pole oriented umbrae there. So we'll just have to see if that one gains complexity or not. And do we have a new sunspot here? It's a new sunspot there as well. Or is that an old one? I can't remember. I think that's the one that's inside the coronal hole. In any case, let's move on to show some imagery of iron star. Yes, 3 different species of ionized iron here. 335, 193, plus 94 angstroms. That's where we'll close out our space weather portion of the video. And we'll throw in meteorology here once again. Meteorology segment coming, because I realized over a decade ago that forecasting the weather is too easy and decided to expand. If you'd like to expand your health, consider becoming a member of the American Better Health Organization through ShoreMed. Now, personal story. I caught COVID back in July. Yes, I caught COVID. And it's pretty hard to get me to talk to a doctor about anything, because generally they'd know a lot less about me than I do. However, I was requesting some medications. I decided to take some steroids to help with the COVID. And I got a horrible sore throat. That was the main feature of it. I was pretty sick there for a little while, but it didn't last long, folks. And I actually used the teledoc service. Yes, I used doctors by phone, which that in itself is worth your ShoreMed membership. There's also virtual veterinarians, all kinds of discounts on things like vitamins, labs, dental discounts of 15 to 50%, discounts on vision services like frames, LASIK surgery, etc. ShoreMed, it's fantastic, and I use it myself. The great thing about doctors by phone is you don't go to a physical doctor. They call in your prescriptions. You just go pick them up. So check out the links below the video and on the homepage to my personal ShoreMed page. And don't forget to press like and subscribe. If you're a new viewer on YouTube, make sure you press that subscribe button, press a notification bell. You may even see a notification when we go live, and check out our playlists as well. You can find all kinds of playlists on there, like Terms Defined, Daily Space Weather, Cosmology segments. And don't forget, the Diamond Anvil, Too Hard to Smash. Even some driving, riding, and pro tips showing up on the channel. Don't forget to follow us on Twitter if you haven't set up a Twitter account. I know about the pathetic censorship on Twitter, as well as on other big tech platforms. I mean, I've been talking about it for 6 years. That's part of the reason why we have barely 300 subscribers on Twitter. 300 followers, whatever they're called. And there are some words that will not be said because this is a YouTube video. But in any case, twitter.com/smashamash. You'll see shares of things you'll only see by joining us on Twitter. So check us out over there. If you don't have an account, create an account. You're unlikely to get banned. We also regularly stream live to Twitch. Twitch.tv/smashamash is our Twitch channel. And by the way, we send out email pushes to the Smash team. There is even a bronze level that's free. It doesn't cost you anything. And you'll get additional content if you join at the silver or gold level. Again, we send out email pushes for things like tsunamis, geomagnetic storms, new sunspot groups rising, and things like that. Smashomash.com/Smash Team. Support the channel via subscription services. Similar to Patreon, just superior. Now, we are still on Patreon as well. Today's featured product is, and these are our products here listed on our Redbubble merch shop in order of best selling. Of course, some words appearing there that will not be said on the video. Today's featured product is Do Not Pole Vault the Caldera. If you visit the link below the video, you'll find that page on Redbubble there in order of best selling. And we implore you, do not pole vault the Caldera. I'm currently wearing the Do Not Pole Vault the Caldera socks. And it is a message of hope, folks, because your finest days lie ahead. Things may seem badly at the moment. Things shall improve. So don't pole vault the Caldera. It could be unhelpful. If you are visiting a volcano, let us know. Hit us up on Twitter, and we'll feature your imagery. But whatever you do, don't pole vault the Caldera. Do pick up some sweet merch from the merch shop and give Smash staff a raise. She desperately needs one. Links to that below the video as well as on the homepage. We're paid just this side of nothing to put the videos on YouTube. And welcome to the Neo-Renaissance. Again, the most detailed space weather and imagery of the sun you'll find anywhere in the world. We've been doing it over 5 years. And thanks to all of you viewers out there, all kinds of links to our social media and other accounts there on the homepage at smashomash.com. Moving into the realm of meteorology, we're starting out this segment looking at ocean currents. And there you have the Gulf Stream, still making its way up to the area in between Ireland and Iceland. Why? Why are we showing it? Well, because it was not a year without a summer, despite people forecasting it for the last 6 years. No year without a summer, folks. It was very hot in Europe and very dry also. Rivers drying up in Europe. A lack of rain and a lot of heat leads to dry rivers, yes. Anyway, those are ocean currents. Let's show the whole world. And that's where the motion of the ocean is occurring, if you weren't aware. And let's get to our regularly scheduled wind maps. So here is your surface wind scenario for the eastern world. We are seeing some warnings here for places like Taiwan, as there are some quite high-speed winds there. We won't zoom in, but near hurricane force winds, certainly, if not beyond hurricane force winds. It's a very compact low there. And here are the jet streams of the eastern world. Here are the jet streams of the western world. Getting some cold air blown down into Pennsylvania here. Some Great Lakes air from eastern Canada showing up in Lehigh Valley, PA. Here are the surface winds. Surface winds of the central world. And jet streams. Here's your weather.gov map. If your county's lit, click your county on weather.gov. Some additional flooding forecasted here for Texas and some excessive heat on the west coast. Here's your temperature anomaly forecast based on the GFS model. And some pockets of very cold air there in the southern U.S. Some pockets of very hot air in the northwestern U.S. Also portions of central Canada seeing anomalously hot temperatures. Keep in mind temperatures shown here in degrees Celsius. That's your GFS, temperature anomaly forecast for the next 72 hours. Here's your total accumulated precipitation forecast based on the same model and the same time frame. 72-hour GFS total accumulated precipitation forecast shown here in inches. Some heavy rains forecasted there for southern Georgia and for portions of West Texas and East Texas. Some pockets of some pretty heavy rain expected there. And let's move on to another wind map. This is our windy.com wind map. And a strong low here off the coast of Oregon. Some strong winds there in southern Alaska as well, some onshore winds. And let's just switch to pressure. Strong low continues to be in northeastern Canada. And there's that strong low off the coast of Oregon. Next, your NASA GOES lightning mapper, and we're seeing some anomalous data here once again on this. Let's show that. That is probably some electrons on the aperture itself messing up the imaging, as lightning don't happen like that. It's not directed energy weapons. It's not Project Bluebeam or any other nonsense like that. That is the imager, probably electrons gathering on the outside of the imager, creating some anomalous data. And let's switch to a real-time lightning map real quick. Here's your lightning map from lightningmaps.org. And I don't see any terrestrial lightning here in the U.S., so let's move on. Just give it a minute. This video was originally streamed live to twitch.tv/smashomash. Here's your U.S. Doppler radar map. And the Doppler radar, folks, if you're not aware, is ground-based systems that are measuring vertical motion of water droplets in the air column. And I don't know why it's working like such crap, but it certainly is working like crap. Let's move on to show satellite imagery. Here's the satellite imagery showing shortwave radiation. It's 3.9 nanometer infrared radiation from the GOES Interactive Weather Satellite Suite. And here is the water vapor map, which is totally sweet. We've got dry air in the east, dry air in the west, and moister air in the central portion of the country. Here's your recap. Doppler radar. Some Doppler radar, and some missing Doppler radar. I don't know what's up with it. You just can't find a functional website nowadays. I don't know what the deal is. It certainly is not our bandwidth. Here is shortwave radiation showing clouds and fog. It's cloudy over Texas. And there is the water vapor map to close things out. Thanks for tuning in. Congratulations on realizing that the channel exists. And may that solar wind be at your back.